Hello, and welcome back to the General Physics Laboratory. This week, we will be investigating Hooke's law, which states that the force needed to stretch or compress a spring is proportional to the displacement from the spring's equilibrium position. The spring constant, K, determines the relationship between the displacement and the magnitude of the force. Each spring has a unique spring constant that describes its stiffness. We will conduct a static and a dynamic test to determine the spring constant and compare the two values. For the first part of this experiment, we hang the spring vertically and study how far it stretches as we add mass to the hanging end. For each value of mass, the spring will stretch to a new length. We record the position using a motion sensor. The mass should not be moving during this part of the experiment. Each measurement is repeated for each value of mass to reduce experimental uncertainty. Plotting the weight versus the stretching length should yield a linear trend with the slope being the spring constant. For the second part of this experiment, we set the mass in motion and study how the period depends on the amount of mass on the spring. We start with a large mass on the spring and record with a stopwatch the time it takes the mass to complete 10 cycles. This measurement is repeated 3 times. We remove a bit of mass and repeat the 3 measurements. Now we can plot the period versus the mass. It should show a square root dependence that is related to the spring constant.